Welcome to SIIMcast, a podcast brought to you by the Society for Imaging Informatics in Medicine.
Greetings, SIIMcast listeners. Today we have the pleasure of hosting Dr. Paul Nagy on this episode to tell us about his informatics journey. Fun fact, Paul was the first guest of the very first SIIMcast episode. It is hard to give Paul a proper introduction without going on and on, but I'm going to try and summarize here. So Paul Nagy is an associate professor in the Johns Hopkins University School of Medicine, Department of Radiology, with appointments in the Department of Medicine, Department of Biomedical Engineering, in the School of Engineering and Health Policy, Management Department in the School of Public Health. Paul is the Director of Education for Graduate Training Program in the Biomedical Informatics and Data Science Group in the School of Medicine. He leads the Johns Hopkins Observational Health and Data Science Informatics, known as Odyssey Research Group at Johns Hopkins. This group has participated in multiple studies and been part of about $35 million of grants and contracts since 2021. I should also add that in 2022, Paul received the Odyssey Titan Award for his contributions to the field of observational research. There's a lot more to Paul and his achievements, but it's also worth noting that he is a past chair of the Society of Imaging Informatics in Medicine, SIIM, and the American Board of Imaging Informatics, ABI, as well as a past president of the College of SIIM Fellows. Paul is also an author to over 140 papers and over 200 national presentations in the field of informatics and implementation science. It's always fun talking to Paul, and I hope you enjoy listening to this episode as much as we also enjoyed listening to Paul. All right, welcome, Paul. We're excited to hear about your informatics journey. So without further ado, please go ahead.
Thank you so much. And so, yeah, it's really great chance to tell my story, and I'll try to give some advice to folks who are on their professional development journey as well as part of this. It was fun looking at parts of my career, and one of the things I noticed is that I generally had different eras in my career. And generally, they were about 4 to 5 years in duration, either at an institution or in a role at an institution. And I find that that has been part of my career development. That every several years, I have had to reinvent myself. And so I want to encourage folks that I think this is a natural part of our process. I found in some cases, I was involved with deploying the PACS system and the RISC system and the speech recognition system. And then they were done. What else is there to do except for wait until they want to do it again? And they might not want to do it again for another 10 years. And it's interesting. My career has been about leading change and helping health systems lead that change, and in particular, working with physicians. And so it's interesting how if your job is to help people change, and I like doing it from within the organization, but then I always have to kind of find new things that I can help change. And also find opportunities where I can make a bigger impact for change. And so I actually have 6 eras that I've defined my career around. And I'll talk about before I started my career, I was trained as a diagnostic medical physicist in a radiology department in the School of Medicine. I took classes with medical students, and I spent my time in the reading room. This is in the early 1990s. And I went to undergraduate school at Carnegie Mellon. I am a big data nerd and a computer nerd. And I really enjoyed my time, but I also found myself to be an experimentalist. So I really liked working where I can see the applications more directly. So I really enjoyed my time as a PhD student. But what did I do during my time? I wrote software, and I wrote software that did image segmentation. Back then, I was doing geometric deformable models on fat segmentation and on body CT. I was doing registration based on fiducials, and we were doing skeletonization. So we're doing like feature engineering back then. We did do some neural networks, but they were really small neural networks. They were like 3-layer with a couple of hidden layers, but they were just more for decision modeling. So I really enjoyed that role for image processing. I like to consider myself as a graduate student. I was the PACS system. I was the sneaker net. I would go up to the worm drives on the CT scan, pull them off the CT scanner, and then convert them over to a DAT drive, And so I basically was the file interchange system. And back in the early 90s, it was before DICOM, where we had basically different networks and they were on token rings that were vendor specific. And so, but I really enjoyed my time because I got to spend time working closely with the end user, trying to understand. I am not a radiologist. I am always fascinating watching a radiologist, looking at a screen and looking and finding something that I've got no idea is there. And so I love that. I enjoy like understanding what goes into making that image. And so I really like the physics of it, the image processing and the acquisition. So I enjoyed building phantoms and working in the CT scanner and working closely with the technologist. So I spent my time in radiology and oncology during that time, and I loved it. I ended up, after my second year of my PhD program, I ended up moving into industry because I got married and had kids and I had to get a job. And so I ended up, and I was really lucky because I was based in Milwaukee, and Milwaukee has General Electric Medical Systems based there. And they had an X-ray tube engineering facility. And it was a fantastic facility. It was fun because GE built X-ray tubes there for over 100 years. And the reason they did was because they moved to Milwaukee was because they wanted German glass blowers. And so it was really kind of fun seeing the history of X-ray tube engineering and the discovery of X-rays. And so I'm a big history of medicine nut. And so I had a wonderful time doing X-ray tube engineering. It's a fantastic discipline involving mechanical engineering, electrical engineering, and I did electron optics and high voltage simulation. But what I really got out of my time with my engineering was, one is I love being part of a high value team. I had to trust the double E. I had to trust the Mechie who did the vibration analysis, and I would do the high voltage. There was a real emphasis in industry on managing people, which I often don't see in medicine or in academia. It was actually a cross-matrix organization that had a functional manager and a program manager. This is the mid-90s under Jack Welch, when management was a big thing, and we did a lot of management training. And on top of that, what I really remember the most was our lab in Milwaukee in 1996 was the first place that Six Sigma was implemented inside GE. And what I took away from that, I actually fell in love with Six Sigma because as an engineer and scientist, I actually didn't know how to talk to the business leaders. I always thought that data always wins, and that if I could show someone data, they would just act upon the data, right? That's a typical scientist perspective, right? Well, my analysis says this, so we should do that. And that's not how life works. And so I learned with Six Sigma how to communicate across the cultural chasms between the technical and the business, as well as the clinical. What I learned in the reading room was crossing between the clinical and technical. And with Six Sigma, I learned how to communicate between the business leadership and the technical. And for me, that was like quite a eureka moment. And so I really liked progressive management. I liked this idea of following the scientific method and using it as a means of building better products. I really liked project management, combining it with the scientific method. And then on top of that, there's also a bit of behavioral psychology, of understanding how teams form, how teams try to address issues. And so I became a huge Six Sigma fan. I've actually, in my past 20-some years, I've actually mentored over 200 Lean and Six Sigma projects. And I find that it's a great way of combining quality and informatics. For me, are two sides of the same coin, where whenever we talk about technology, we always say, well, technology is only 1/3 of the solution. 2/3 of the solution is workflow and people and users and adaptive leadership. Well, guess what? That is the same thing on the quality improvement side. So for me, I got a great training in behavioral psychology, quality leadership. One of the things I did was I was involved with X-ray tubes, and I would measure focal spots, which are the very small impact area where the electrons hit the target and the tungsten target, and X-rays are created. And so I built a very novel way of measuring focal spots at GE that was down to the 10 micron level. And so what was interesting was, so I built an instrument to measure focal spots. And so like every quality project wanted to use my measurement methodology because it was more sensitive. And so I actually got involved with lots of QI projects and looking at ways that we can optimize the heat loading. I was involved with a couple of patents at GE. I learned I got $1 for each patent that I submitted, which we put on our cubicles. And so, but what was interesting was I also got very frustrated at GE. And it was not because of actually GE. I really enjoyed my time at GE. I enjoyed going up the understanding how to combine management. And I worked alongside the manufacturing group, and it was fantastic. And so I really learned how to bring something from engineering to manufacturing, which is not trivial, and often something that we learn from developing software and then supporting it in a production environment is very different. And there's very different cultures between service and engineering, and how one is focusing on making sure nothing fails. That's a service culture. And then how we have like more of a tolerance of failure and creativity in a engineering culture. And so I realized how different cultures interact with each other to actually create new solutions. And so that was really a meaningful part to me. But I also felt I was frustrated with understanding what customers were looking for in products. I feel like I missed my roots being inside the health system. I feel like the technology leadership is often ignored. There's often business leaders in hospitals, and there's clinical leaders, but there's often not technical leaders, especially in the IT space in the 1990s in health systems. Many of them barely had CIOs. And so one interesting thing was my old chairman was presenting at an advisory board meeting, and he said, he recognized me. He was an advisory board member for GE. And he said, weren't you that guy that helped everyone in the department with their computer? And it was. I was actually the PC support for the entire department as a graduate student. And I actually think it actually got me my job. And on top of that, it was a valuable way of really understanding end users and helping them with technology. It's helping them where they are with technology. And so I ended up moving back in. And so he said, our chairman was a phenomenal chairman. He said, we're going to go digital to this thing called PACS. And I've been told it's helpful to have someone who knows something about computers. And that's, the state of how technology is adopted. And so I joined a medical physics practice at the institution at the Medical College of Wisconsin. And I made a great deal. I said, I'll take care of the IT. You take care of all of the room surveys and the lining calculations, and I will take care of the PACS system. And so my first era was in industry, and I really always cherish my time in industry. I really appreciate how effective people were on executing and getting things done and managing time efficiently, and also what a high value performance team was about. So my next era was as a junior faculty member at the Medical College of Wisconsin. Between 2000 and 2004, my job was to deliver a PACS system. And so that was really, I had been involved with RSNA since the mid-90s. I've been involved with SPI, with image processing. I had been involved with SCAR, which was the predecessor to SIIM, but not heavily until I signed up there right in 2000, where it was my job to move into the PACS environment. So that's when I found SIIM. I found a wonderful group of scientists and physicians who really broke down the cultural barriers and were understanding this technology. This is still at the early innovation phase, and we hadn't crossed the tipping point for adoption. LCDs were still too expensive. Monitors were hideously expensive. Storage was still $1 million a terabyte. And so we hadn't crossed over the tipping point for PACS widespread adoption. We were still in the early adoption phase. And yet I really had a great time. And so I use Six Sigma as my decision methodology for breaking down technical, clinical, and business needs. I basically had key performance measures for each of those three actors. And I had basically a scoring system, and we evaluated all these different vendors at the time. And we really found, the new generation of vendors that were really focusing on IT, trying to use web protocols, trying to build scalable processes, no longer focusing at the time. PACS was still treated often too much like an imaging modality than an information system. And I find that was really challenging, because then it gave me heartburn to think about how to make sure that the thing never fails, and looking for single points of failure in architectures where I spent a lot of time with a lot of vendors. And I really built a lot of great relationships that became engineering relationships with these vendors as this product started maturing. So between 2000 and 2004 is really where I spent my time doing PACS. Mahana, you had a question?
I was curious. So those early days, those PACS systems, were they homegrown solution, or were they actually purchased?
They were absolutely purchased. So you would need to have it purchased, because even in 2000, there was plenty of PACS vendors out there. They were really, the challenge was the PACS, it was really dependent upon your imaging modalities, which ones they were compliant with. When, DICOM became a standard in 93, and it started gaining adoption, but it was really with the VA, it really became much more predominant in the early 2000s. And so with the early 2000s and DICOM, it really drove some of the keys around the criteria. But still, a lot of the packages have, of course, bolted on DICOM with a merge box. And so they were not inherently really trying, they were still trying to take their older system and still make it meet the criteria for an RFP, but that also introduced a new independent single point of failure. And some PAC systems I found were like archaeology digs, where they had vendors that were bought within vendors that were bought within vendors that ended up having 3 different operating systems, even on the server side, trying to manage, and different databases, even on the server side, to manage different queuing of how it would do the storage and forwarding of the images. And so I found that the technological debt is something that you really have to look at, and whether they treat it as an engineering exercise or as an information system. So I kind of still felt we were really still tied to that, and that I really wanted a vendor that would work with me to build what I considered a 4-9 operation. There's a great science for how to manage an IT system, for configuration management, availability monitoring, performance monitoring, so that you know what's going to happen when some points of it fails, so that you can have a plan in place to be able to make sure that you don't have patients sitting on the table, where they're not having access to their images. And so this was fun. The other fun thing that I had, as I spent a lot of time with the radiologist again, and I really enjoyed working closely with them and moving them. And this is where in Milwaukee, we had this incredibly big ballroom, one central room with all the different specialties, except for neuro. They had their own room, they're special. And we had them all in one room where all the referring physicians from around the hospital would come in. We had like 20 different alternators. The place was loud, but there's always like medical students in there. It was always like a train station in the reading room. But it was also really exciting because there was just a lot of dynamic interaction where our radiologist really had a close relationship with all the referring physicians. And so we actually was able to, as part of our PACS initiative, we found that by using modern IT methods, instead of buying storage at $1 million a terabyte, we would go to NAS, we would be able to use different techniques that would really save a lot of money, that we were able to put aside to actually spend money on the physical plant, the reading room design itself. So getting Herman Miller chairs. We actually ended up doing a whole project with Herman Miller where we had pink noise generators in the room. We designed inverted cubes. We had sound penetration barriers between the walls. We actually had different lighting techniques. And so we actually did a lot of fun with the understanding the ambient reading conditions that enabled teaching, consultation, where the people coming into the room would go to. We had larger workstations for larger groups, and yet also had allowed for basically the section behavior of several people covering an area with residents and fellows, and being able to do it as a pod. And so it was really fun trying to design that type of interactive zone. So that was really kind of my involvement with them. And I also really became much more heavily involved with SCAR at the time. That was really, I learned so much from other sites, from my colleagues, from the pioneers of PACS and SCAR. And so I was able to take that and try to apply that as an experiment with our PACS implementation in Milwaukee. So it was a fun project, and it was really a successful one in that deployment. But I ran into that problem where I deployed the PACS, we actually deployed the RISs, and we were playing with speech recognition, and we actually deployed the Epic RIS system, which was in 2004, which is before it was officially Radiant. This was when it was still an engineering exercise with Epic. That was also a lot of fun. But I really found that I wanted to grow. And also I found that there was a business model where the faculty were a contract with the health system. And so there was a divide between the health system and the physicians. And my job ended up becoming the representative for the physician because I was on faculty with them. It was very hard for me to do I could only do win-wins. I couldn't act as one organization. So in 2004, I was recruited to the University of Maryland, where Elliot Siegel had put together an incredible shop. So that was my second phase, was in MCW, where I worked within a department, and we were able to implement it. I ended up doing a lot of Six Sigma as part of the process, the PACS implementation. And it's really where I started also recruiting some high school students and college students that started developing some of the informatics tools that we started publishing on for providing. One of the things we saw with the deployment of PACS was we saw a lot of sterilization between the radiologist and the technologist, radiologist and referring physician. And so we started trying to build some communication tools to allow feedback so that we can maintain that relationship in a time shifted and a geography shifted world. And so we started seeing some of the challenges of the next generation that we still see today, where how do we maintain collegiality and communication between our technologists that are creating the images and our referring physicians that were working with our radiologists. So I was recruited at Maryland. I was very excited because one was the department was a joint department. So the clinical practice, the health system, and the faculty were part of the same organization. So I could actually do more things on the health system side. And also I could play a larger role. So this is where we actually helped found the Imaging Informatics Fellowship that I started teaching in 2004. Nabil Safdar was our first fellow after Khan Siddiqui. That was really a lot of fun. A lot of SIIM leaders went through that Imaging Informatics Fellowship where we would really train them in working closely with engineers. We actually we changed the PACS vendor and we implemented a PACS system. And what was really fun with it is we actually built an engineering relationship with our PACS vendor where the PACS vendor had 100 software developers, but we were able to build a program where one of those developers would spend time with our radiologists and with us throughout the year on campus, and they'd be able to be eyes and ears for their developers. And we would try to help them translate across that cultural chasm between engineering and clinical use. And that was also really a fun exercise in trying to understand how do we really build strong engineering relationships with the people building. There's too many degrees of separation between those building our solutions and those that are using them. And so we ended up we started building an informatics lab, and we ended up creating a web-based environment that would integrate directly into the PACS system. We ended up building 27 different IT applications to help visualize or do quality control or help understand utilization or understanding the reporting process. And that was a lot of fun. Ended up spinning off into a startup after I left. But the bigger thing at the time was when I went to Maryland in around 2005 was where SCAR was beginning to really thinking about standardizing the role of the PACS administrator. So at the time, PACS administrator would only get certified in their vendor. So they'd be stuck within their vendor, and they could only leave their organization to another organization that had that vendor's solution. And so we wanted to really improve the whole profession. And so I undertook with George Bowers the first job task analysis of the PACS administrators. We published this work, and we helped form the American Board of Imaging Informatics in 2006. And this was really an effort between SIIM, which turned SIIM in 2006, and with the ARRT, which is the American Registry of Radiology Technologists. The ARRT has a lot of experience in building really solid, psychometrically sound certifications. And I got schooled in how to write questions. I thought I wrote questions well, but I really didn't. Understanding stems and distractors, and to think of it as a psychometrics as a science is really very interesting, where we had to validate our questions, and we actually learned how to actually make sure that our test, even though we have a whole item bank of questions, was consistently difficult at the same level every time we give the test. And so we gave the first ABBY exam was in paper at the SIIM conference in 2007. And so we actually delivered that. That was a monumental effort. So creating that item bank, building the validation of the ABBY certification program was probably the largest SIIM volunteer effort that I am aware of in our history. It literally took thousands and thousands of volunteer hours to build all the questions, to validate them, to build out the item banks, to build the test content outline, and then to build the psychometric validation around it. So we had several different committees, and this was a large effort. And I was very proud of our community putting this together to say, let's create a generalizable resource so that a PACS administrator can be useful and work across different vendors, and also realize what they ought to be doing to make a successful PACS. A lot of PACS administrators didn't realize part of their job was ergonomics and understanding workflow or refreshing the technology. So there were sides to that we felt were part of our job testing out that really showed us that we could really also show a vision for how we could grow the profession. So I've been Abby became incredibly successful. We have over 1,000 diplomates who've gone through that program, and it really helped us with the tipping point of the technology getting cheaper, having people available who knew how to use the technology for systems to really go full speed forward with embracing the technology within our field. So we really, with the DICOM standard, I felt we really crossed that tipping point. And it was really funny. From 1990 on, most PACS experts would say, we're going to cross the tipping point in 5 years. And it's like every 5 years, we're saying it's 5 years from now. And it really happened in around 2007. And a lot of it was that cost of storage and LCDs, along with the number of people who were qualified in implementing the solutions. The costs really did come down considerably. And it was just a very exciting feeling in 2007 where everyone started to adopt. It was one of the first major IT systems deployed in healthcare in terms of a front end user system. We learned from mistakes in CPOEs and other EHR systems, but this was really one of the reasons why radiology became digital at an early stage.
And I should mention, because you mentioned thousands of volunteer hours creating Abby and the test content, that effort is actually still going and is going very strongly because that test content is constantly evolving. And if I recall correctly, they actually do plan like a relatively major overhaul in the next year or two. So it's nice to see.
I wanted to make it about a profession where there's continuing medical education, that you have to be a knowledge worker. You have to be constantly learning because technology does not stand still. We have seen that. I've had the pleasure of seeing that over the last 30 years in radiology and IT, is seeing just how fast and fluid the field is. And it's amazing how once we think we've gotten into a good spot, then all of a sudden ChatGPT comes and changes the game. And so what we see in technology innovation and adoption is overlapping sigmoids of technology. They have a slow curve, then there's a rapid adoption, then it levels off. But we're seeing so many things happening in succession that it becomes consistently moving forward as a field. And this is how we define Moore's law for the cost coming at a doubling rate of capacity, even at the same cost. So I had a lot of fun at my time at University of Maryland. I ended up being there for 7 years, from 2004 to 2011. One of the challenges I had there, I really started finding radiology such an important function within a health system. And it's so tied to the emergency department. It's so tied to the operating room. It's tied into so many processes within a health system. And I found that I really wanted to take more of a system role. And that was really kind of where I wanted to be more boundaryless. And so in 2011, I ended up leaving University of Maryland and joining Johns Hopkins. One of the things I liked about Johns Hopkins is it is integrated medical center. So the whole health system and the physicians and the hospital are part of the same organization. So again, it has that alignment that I really feel is critical for us to be able to drive change effectively. Looking back, my mission is really just working with clinical leaders who I can help them with understanding their data, helping them bring technology in, and helping them really try to re-engineer their care delivery process with whether it's quality methods or with technology, or more likely a combination of both. So I became the chair of the American Board of Imaging Informatics in around 2008. And then I left for Johns Hopkins in about 2011. At Johns Hopkins, between 2011 and 2015, I built a lab. I built an informatics lab within radiology. We ended up growing to about 9 people in the lab. We started working on enterprise initiatives in other departments. I started working closely with the Armstrong Institute for Patient Safety and Quality, which is focusing on how do we re-engineer care delivery. And informatics and quality, I think, are two interesting things about them is most of the problems / opportunities congregate around organizational boundaries. What you really want is a great solution that crosses radiology and the emergency department. And so I became frequently more involved in doing things at a more systemic level. And so it took me a couple of years, but in 2015, I founded the Johns Hopkins Technology Innovation Center. I really felt like a lot of the solutions are going to be useful for radiology, but they can be just as useful for other departments as well. And so I, along with the chief technical officer at Johns Hopkins, we took my informatics lab, and he had an engineering team of about 15 people that were based at the enterprise level that was building server apps. And we combined the two teams, and my team was the front end team for design, They were the back-end team for development. So we ended up becoming the engineering shop, the software engineering group with inside Johns Hopkins. And what's fun about that was we really tied this to our mission, that our mission is to partner with clinicians and to help them build applications. And at the time, of course, we were seeing a lot of medical digital apps beginning to be developed in the App Store for Apple and for Google. We see a lot of mobile applications being developed with integration into Epic. And so we really try to build an environment where we could wire the clinical IT system for helping us doing integration, for helping our providers to re-engineer their relationship with their patients. And so we ended up building the first medical app on the Apple Watch we did one of the largest clinical trials for epilepsy called EpiWatch that was looking at the accelerometer and the pulse rate for trying to measure the aura of seizures for epilepsy. That was a really exciting project. We were streaming data through the cloud for that one. So the TIC, the Technology Innovation Center, and today has actually over 65 software engineers in that group. So we found that there was a large need for a centralized group that could share engineering practices. Still 95% of solutions are commercially provided within Johns Hopkins, but we found two things that are often needed even when we buy clinical solutions. One is people who are really good at glue, at integrating solutions together. And so we actually worked closely with the HL7 streams. We had the DICOM streams. We had actually an enterprise service bus we use called MuleSoft. We do all kinds of integration work where a lot of the innovation is just gluing the systems together so they work more seamlessly for our end users. And then also we really brought in our design thinking perspective where we could iterate with end users in that development. So the TIC, we ended up working with a lot of physicians, helping them go after grants. And we even created a medical accelerator called HexSite, which we've now been running for 9 years. And so that's a program where we bring an engineer, a clinician, and a designer together, and we help them do the Stanford D-School evidence-based entrepreneurialism program where we try to help build a digital solution and try to help them do that internally within the Johns Hopkins system. So it's still, for me, it's the same process. I want to take a clinical lead and I want to try to help get them as much resources as I can and then help them experiment in their environment to help lead change in the process. And so the TIC was really something that I'm super proud of and excited that it reminded me of my time at doing X-ray tube engineering. I wanted an engineering group. I wanted an engineering group closer to the clinician where I could be embedded with them and working with them directly to build these solutions. And today, really, it was about the IT environment. So my goal was to build this engineering shop like I had at GE, but I wanted to build it inside a health system where we really have much better integration into the clinical data stream. So that was my role from 2015 to 2020. And I still have that hat today that I really enjoy. But then a little thing came along. So then what I found was I had been teaching my informatics fellowship, imaging informatics fellowship since 2004. I made one at Hopkins in 2011. I started growing that informatics fellowship for analytics. I created an analytics training program at Johns Hopkins, and I created an entrepreneurial training program, the HexSite program. And so in 2020, I actually took over as the program director for all of our formal graduate training program for our master's and PhD program in biomedical informatics and data science. And so I ended up creating about 8 new courses on hands-on data science. I really wanted to train informaticists to be able to work, to do what I enjoy doing, being able to partner with physicians and to lead change. And so I ended up creating several courses. I got 150,000 patient records out of Epic. I de-identified them. I provided them a secure environment, and I created a training environment where all of our students are interacting with the data directly, where I wanted them to see how messy our raw data is. So if you work with DICOM data, you'll see there's lots of fields in there that are not as conformant as you might want them to be. And the same thing is true with EHR data, that you get either an HL7 or FHIR or directly from an EHR vendor. And so I really wanted to give people hands-on data science skills working with the actual data. So we actually create all kinds of classes for curating the data, for doing FHIR interoperability, for doing imaging deep learning, for doing Python data cleaning, working with databases. And so it's really important. You can't really learn data science until you can actually get your hands on the data. So I really have enjoyed that role of teaching. I always wanted to bring an army of technology professionals like myself into healthcare and train them to be the partners with the clinicians. And so that's why I have really enjoyed this role as the graduate director. At the same time, the pandemic struck, and the pandemic, I know, it's changed everybody's lives. It certainly changed ours greatly. And one of the things I found about it, which really struck me, was it was really the first unknown disease in our lifetimes where all of the outcome data was sitting in the EHR, because the patients would get sicker and sicker. They'd stay in the hospital, figuring out which patients are going to need a ventilator. As we were seeing the disease unfold and trying to understand it, I was part of the COVID response team, which was the team responsible for delivering data for helping us understand the disease. So we actually supported over 200 IRBs over the next couple of years and helping get Epic data and EHR data into the hands of clinical researchers. We developed the severe COVID adaptive risk prediction model, which we actually deployed into clinical care at Johns Hopkins. And I really found the passion for why we need to standardize and curate our EHR data. As part of this process, I was commissioned by the senior leadership to convert our proprietary EHR data into a common data model that was curated for research purposes. I started being involved with Odyssey, which is an open health data science and informatics initiative, which is an open access, open science community that does open source software that has built an open data model. And what's exciting about it was that, you convert your data to this format, and what you can now share is you share code between sites instead of sharing data. Data has all kinds of risks. There's all kinds of privacy issues with this data. And so we found that we could really start doing much better science by collaborating across systems. One of the challenges we're facing today in 2024 is that many of our AI algorithms are really stuck because they're developed out of single source single site places. And I feel like algorithms are learning the site before they're learning the disease, and that they're getting tailored by the protocol, the manufacturers, and these things that are influencing the training are causing it to have real world performance drops when we deploy it in heterogeneous environments. And so I think what's going to be critical is for us to be able to collect large data. And, while we do have 2.5 million patients at Johns Hopkins, that's not enough when we start talking about rare diseases. We really want to start seeing data. We want to be able to collect our analysis from a much larger catchment. And Odyssey has got over 400 sites around the world with over 960 million patients. And so as a data scientist, it's really exciting to have a process where I can use federated learning without putting patient data at risk, where I can actually aggregate that knowledge together to be able to look for really better disease outcomes, response to medications in that process, and have it in a reproducible computational way. I've been really excited about Odyssey. One of the things that I've been doing is I've actually created an extension for bringing imaging data into the Odyssey model. Odyssey is great because it has the overall context of the medical record. It has all the labs, the meds, the procedures, the diagnosis codes, but it doesn't have the images. And the images are where a lot of the really granular phenotypes or the effect of treatment can be measured. And so I feel like it's peanut butter and chocolate. So I've been really excited. We have a paper accepted that's about to be published in the Journal of Imaging Informatics, which is going to show how you can bring imaging data combined with the EHR outcomes data together to really do novel cohort definitions and build to do much better outcomes research. And so I feel like this is going to be another great step forward. And so go ahead, Mohan, you have a question?
Not a question. I just wanted to add a couple of quick things. So for those listening at home, it's pronounced Odyssey, but it's actually spelled OHDSI. So in case anybody wants to look it up. And it's too bad we only publish audio from these podcasts, because if you could see, Paul actually has his video right now. And when he says he's excited about Odyssey, he's not joking. So he's actually used his woodworking skills to recreate the Odyssey logo, which is sitting behind him on the wall. So he's very, very serious about this. For what it's worth, Odyssey is very exciting. I've been from a distance watching the work you and others have been putting into Odyssey, and I think it's really cool.
It's actually something that I've loved from SIIM. One of the fun, exciting things that I always loved at SIIM was the open source community. DICOM's success as a standard is due to, in the early 90s, two reference implementations were created, OFIS and DCM from...
DCMTK?
Not DCMTK. It was from the University of Washington University, excuse me. Those tools really helped, catapult the DICOM field and adoption of the standard. And the open source community really helped people train in DICOM and learn how to use it and learn how to do interoperability. And so I've always been really excited to do a lot of the imaging science, a lot of the PyTorch, all the best deep learning libraries are open source. And so it's been really, imaging has gained so much from the open source community. It's exciting to see another open source community working at the observational EHR record level and trying to combine the two. So it's been really validating watching the open source helping us push the boundaries on how we create evidence in medicine. And so one of the things we found with that, now that we can really collect data through modern EHR automation, and we can actually really reduce the cost of a lot of clinical registries and how we actually look at disease. So we've been helping a lot of our clinicians go after grants and help. We actually have grants we were awarded a $14 million grant with the NIH for maternal health centers of excellence and with the CDC modernization efforts and with the FDA as part of the Pure ID project. So it's exciting to see this time where we're beginning to see computational, phenotypes of cohorts and definitions. And I'm certainly excited. But for me, what's really fun about this, I've been doing this for 30 years. I find it's the same recipe that I've been doing this entire time. I really enjoy working with physicians. I like to see the value of my work. I get super excited when I see a physician using my tools. It scares the bejesus out of me, makes me extremely nervous, but it's very validating at the same time. I'm like, don't break. Whatever you do, don't break right now. But it's also at the same time, I'm thrilled when I can be involved with them having an impact on the care of a patient. So it's always really validating when I get to see that process. And I really enjoy training new informaticists and data science to learn how to be a partner and understand how to be part of the team science to really become a successful high performance team. And so I am a huge advocate for high performance teams. There's no way you can even scratch the surface of knowing everything that you need to know at the way technology is moving. And so you need to build effective teams. I've certainly enjoyed that process in my career.
So, Paul, first, I'm glad to hear that the challenge in 2011 wasn't dealing with me as your fellow. Second, one of the things you've mentioned multiple times is bringing the engineering, bringing the IT specialist, bringing the clinician, and even the business people together. Now, you've talked a bit about post-pandemic, and a lot of people are now more work from home. And you're talking just recently, a few seconds ago, about team building, right? So how do you see people moving forward with team building when a large percentage are either fully work from home or potentially partly work from home? Because you can many times lose that personal interaction, the water cooler kind of conversations, things like that, which help build the team and also transfer knowledge and where a lot of innovation comes from as well.
Yeah, let me answer that in two parts, because I think one of it is very specific to radiology. As I mentioned, in the early 2000s, I delivered my clinical department PACS system, and we saw the rate of consultations face-to-face drop by 95%. And so we really saw that sterilization of that relationship. And so I've actually felt guilty about that. That was the downside and unanticipated impact of the technology. It was no longer referring to would come down to the reading room and they would not have that conversation face to face. And I feel like it's something that's going to get lost when they're just reading the report. And so I have been striving mightily in my career, but a lot of it just waiting for the technology has been to enable peer sharing. And so we've done a lot of the innovative work in that space, trying to build out collaborative virtual reading rooms where radiologists and references could be in the same virtual presence, where they could see how the radiologist could guide them through a CT data set and show them the pathology and have them work on it collaboratively. We're still at the dawn of that stage. Unfortunately, because there's been 10 years of sterilization, the technology is available now, but we've kind of move that out of our training process. So our residents and fellows haven't been trained in that deep level of collaboration that we used to have in radiology. So I do feel like part of it was there was a technology burden, but now the technology is available, but it's still a little bit immature for physicians and other specialists to have virtual rounding, for us to be able to have a virtual consult. It's still not necessarily the easiest thing to do to be able to see if someone's available, to see if someone's online, to be able to try to be non-interruptive with a consult while maintaining the productivity. And so I still think we have a lot of work to do to truly make digital medicine and radiology collaborative with referring physicians. And I think that's going to be the challenge of this generation, is to enable relationships between radiologists and referring physicians through our digital mechanism when they're now going to be clearly geo-separated. And how can we make sure that they can have a channel for informal or for collaboration where so much information can be passed? I do think you can do digital team building with teams and with remote presence. And I totally agree with you that there's still some things that are lost, but I would still say that the technology in Zoom and Teams are still pretty immature, and they're changing pretty quickly to allow us to have better informal collaboration. Most people were using email before they moved into messaging, and they found that by using messaging we could have a lot better collaboration that could be more productive than with email. So I still think that the tools themselves are immature in us being able to collaborate and to do actual. I think it's good at one-on-one relationships. It's not as easy to build team dynamics within a virtual environment. But I'm hopeful. I'm certainly seeing that space being invested in heavily by the major vendors.
Paul, thank you so much for being on this episode. And you've touched on a lot of things. I actually wanted to touch on a number of quick things that you brought up, or maybe sometimes glanced over. So, random fun fact for the listeners. SIIMcast's very first episode was actually an interview with Paul Nagy. You were the chair of SIIM at that time. So, Paul, I don't know how this makes you feel, but we're in season 7 now. It's been 7 years. It's crazy.
Well, it makes me super proud because I think this has been a really valuable asset we've always wanted to make SIIM as collegial as possible. We always wanted to also have it to be accessible for future leaders. We want them to say, this is a volunteer organization, but not only is it a volunteer organization, but it's a very collegial one where this is where we want to coordinate with each other and be able to learn from each other. So I'm excited because I feel like this helps bring the formal leadership, makes them much more approachable and makes people understandable of that. Oh yeah, they could do that. They can be involved in those committees. It's really just people who are interested in working with others and sharing.
And then one thing you also glanced over in your history with SIIM/SCAR is, when did the jokes about being twins with Don Dennison start?
Oh, so that started really around 2000 and I'm going to say 2007, 2006. And so when I was at Maryland, and it's around 2006, we started working closely together. Don is really one of the best PACS architects in our field. He made such tremendous contributions. And so we started working together closely at Maryland, and I kept pulling him in to more activities within SIIM. It was quite funny. Now, if you know Don, we're actually not very much alike. He's an incredible individual. His attention to detail is amazing. But yeah, I think the doppelganger joke started around 2007 or so.
That's awesome. Speaking of which, you also touched on another important one, which is when you started pulling Don into SIIM. And that's also one thing that you've had a reputation for. You have had a reputation for being the guy who tells people to do things, but in a very gentle way, because I'm one of those people that got voluntold to do something. But I will give it to you. You've got a very good enabling, empowering way of getting volunteers involved with SIIM. So kudos for all your work over the years.
Thank you. What I've learned about life is I actually grew up in working for, philanthropy organizations. So in college, I was doing Habitat and Red Cross. I was heavily involved with disaster services. So I found it's actually an important management methodology that you treat your employees like volunteers, because they might show up for work. But the truth is, if you want to really capture their passion and their interests and their ingenuity, you have to understand them, and you have to understand what drives their purpose, what drives what they're trying to master and what they're trying to grow, and then trying to find them opportunities that grow them. And so there's a whole stream of business literature around servant-based leadership. And so really my job is to try to understand people and try to help them provide them opportunities that can help them grow. Like for instance, one of the things for me, the year was 2003 in Milwaukee. I had delivered the PACS and the RIS and the speech system at Milwaukee. And I was like, what am I doing next? I was struggling because I was like, I just felt like I wasn't adding value. And I actually started growing within SIIM. And so I found that, you want to make sure that, I was able to find opportunities for growth. Sometimes you can grow at work. And I found that societies like SIIM are fantastic for growth, even, if you can't grow and take on new challenges within your organization, you can also do things within a professional society. And so I found that really helped me greatly in not only helping me grow and learn, but it ended up providing me the opportunities to advance my career.
It's always a tremendous pleasure talking to you, Paul. Thank you so much for your time here. Before you wrap up, any closing thoughts on your end?
SIIM is such a unique and wonderful community, and we're at the best time of IT implement. I would never, this is the best year, the best time to be involved in PACS, in IT, in medicine is right now. Seeing all the AI algorithms being involved with how they can improve care, understanding the new imaging modalities, understanding how we can really deliver results throughout the enterprise. And it's just really exciting to see that, but the same old principles really do apply. And that really it's about understanding and building a trust-based relationship with providers so that they can embrace this new technology and get value from it. It is really trying to help them. That need has not only not gone away, it's only gotten larger and larger. And I feel the strain of like physician burnout and all the new technology and how they're still using fairly immature information systems for how they retrieve and aggregate data for understanding the complex patient medical records. And so I still feel like there's a lot of growth ahead and there's a lot of opportunities for us as we move forward as a field.
Excellent. Thank you so much, Paul. As always, highly appreciate it. Appreciate your time. And thank you for your leadership and all your work over the years.
That's my great pleasure. Thank you so much, Mohammed.
SIIMcast has been brought to you by the Society of Imaging Informatics in Medicine. Please visit our website at SIIM.org for more information and educational content, including webinars and an archive of prior episodes. Please follow us on Twitter at SIIM_tweets. Thank you to our listeners for your continued support.